Forces F1, which is 3I plus 5J newtons, F2, which is 4I minus J newtons, and F3, which is negative 2I plus 3J newtons, act on an object. So the first thing is, in part A, we want the resultant force, which we can get by doing F1 plus F2 plus F3. I'm just going to express them as column vectors rather than the I as J's. And so that would be 3, 5 plus 4, negative 1 plus negative 2, 3. So with the I components, I've got 3 plus 4, which is 7, take away 2, which is 5. And then with the J components, 5 add 3 is 8, take away 1 is 7. And we could put that back in IJ form as 5I plus 7J newtons. So in part B, we're asked to state the direction the object will accelerate, given it as an angle to the vector I. Well, we know that the vector I is horizontal. 5I plus 7J would go in this sort of direction, where this is 5 and this is 7, and then we want to calculate the angle theta. So we have the opposite and the adjacent, so we're going to use the tangent, and so I'm going to do shift tan of 7 divided by 5, opposite over adjacent, and then that will be 54.5 degrees, correct to 1 decimal place.